Hi there everyone, K4DBZ here with a new project from the workbench. Well, if you're watching this video, there's a good chance you're familiar with this board. This is the NinoTNC. This is actually kind of an old one, the A3, but it's pretty much the same as the modern board. This is a KISS TNC for doing packet radio, and I'm not going to go into too much detail about how this thing works because there's lots of information on the website, which you can see there. The thing I will talk about is the conspicuous absence of the USB to UART chip that is on this board. Interesting. So this is normally what allows the computer, the host computer, to talk to the TNC, is using a chip which usually sits right here on this U4 header. Well, you might notice that buried, sort of hidden underneath this, is a very interesting little breakout, J5. It's normally not used. And what this does, if you can see the text there, is this breaks out the UART pins from the PIC microcontroller. Well, here's another one. Same situation. You can see that the chip, the USB to UART controller is missing. And if we flip the board over, we can see what is there instead. This is my new project, the NinoTNC BLE Bluetooth Low Energy adapter board. So this board is the same size, same physical size as the NinoTNC, but it interfaces to this J5 header using some little pogo pins right here. And what this does is it allows the Raspberry Pi Pico, which is this board here, to essentially emulate a host computer. And what that allows us to do with the Pico W, which is all the fun stuff buried underneath this shield thing here, is it allows us to create a Bluetooth interface that we can then relay packets to and from a cell phone. So that's pretty interesting. Another thing right here is an SD card. So this is used for capturing packets, basically doing logging, data logging of everything the TNC hears and sends, and some other components which I'll get into in a minute. So let's look at a quick demo. So I have here an Android phone, a UV5R here in the background, just on the APRS frequency, and everything's all connected up. We can already see we've got some packets here, and those are also displayed as they come in on this little OLED. And let me just reset the board here. I think we should be able to see some stuff happen. All right, so let's see if we reconnect. Yep. Very good. And the TNC should probably transmit. Actually, no, I guess the APRSDroid will transmit. Let me go ahead and send a position. Okay, so I've TX'd, and then I receive my packet back from my ham neighbor, N4EWE, who hosts an APRS digipeater and graciously let me borrow this Android phone. So that's pretty much it. That's the demo. We were able to transmit a packet and receive a packet. A little bit of, status information, like the location is printed out here. And then the SD card right here will have these packets stored in a text file, as well as a binary file that has just the raw data. Yeah, that's pretty much it. Here we can watch it from this side. Let me send a packet. All right, we sent a packet, and we received a packet. There we go. Pretty cool. Okay, so how does this thing work? So here's the PCB as it comes from the manufacturer, or the fabrication house. In this case, JLC PCB. You can see it's a one-sided assembly, so it's got some surface mount parts here and the pogo pins right here. On the flip side is where we would do some manual assembly. So Pico goes right here on these pads. And even though this is technically a surface mount part, it's really quite easy to solder because you've got these nice big pads here and, you know, nice castellated pads along the edge. I find it's very convenient to stick some pin headers on either side to kind of hold the Pico in place, and that will kind of give you really good alignment. The other part is the OLED thing, which are sort of a dime a dozen off of Amazon or AliExpress or wherever. And it's not even required. You know, if you don't want the display, you really don't need it. Just the Pico is the only required soldering here. On the TNC, we do need to actually put a little bit of solder in this header, this J5 header. And that is just to make sure that the pogo pins have a nice contact surface. And once you put a little bit of solder in, you kind of want that little dimple, that little you know, going into the board, which gives a nice seat for the pogo pins. And you really want to make sure you clean this really good with alcohol once you've soldered it. As for the, you know, the USB to UART chip, you can just not install it if you're doing a new build, or, you know, like pretty much all of my boards, I socket my ICs, and so that's it. You can just pop it out if that's the case. Otherwise, you know, you can just take some clippers and cut the thing out, you know, or a more precise kind of approach is to just snip the RX and TX pins off the U4 part, and that will basically prevent it from communicating with the PIC microcontroller. All right, thanks for watching. Check the links below for the source code and design files for this project, which will be up on GitHub. And yeah, leave a comment below with your thoughts or things you'd like to see added to this project. All right, this is K4DBZ 7 3s.